Welcome, everyone. Thanks for joining us today.
We really appreciate all the support on these videos, and thanks to your feedback, we know that you're finding value in them. Today, we're going to be talking about our combustion monitoring and alerting system, which we refer to as CMA, and really just breaking down everything that you can see beyond air fuel data.
Yeah, it's hard to believe that this is already our 5th live event. And if you haven't had a chance to watch our other videos, you can find them on our website, psenergy.com, which is linked in the comments. Now, so far in this video series, we discuss why combustion matters, which was an introductory video to the science around combustion.
Right, and because it's so important, we always start with the relationship between furnace performance and business performance. Knowing that in metal processing applications, every product you ship goes through a furnace at least once
means furnace performance is business performance. And the second key concept is that combustion is simply chemistry. And because of that, there is a right way to run combustion. And when you don't run that right way, there are very real costs to your business. And as we demonstrate in our third video, the real cost of poor combustion, it's not only monetary costs, but also the very real costs of safety, quality, and delivery. And then in the video combustion performance, do you think or do you know? We present data showing real examples of how quickly furnaces in the field drift out of tune and the importance of monitoring combustion to ensure that each burner is achieving maximum heat output without creating emissions. And we introduced the retrofittable combustion monitoring and alerting system. This is an example of the dashboard shown here, which allows you to see combustion performance for the entire furnace, burner by burner.
You watch a lot of stuff in your process, so why don't you monitor the first step, which is making the heat? Combustion performance is not just about the furnace is hot or the flame looks right or I think we're running well. Combustion monitoring is critical to furnace and business performance, and we don't accept I think in any other critical situations. So why should we accept it in industrial combustion when safety, quality, delivery, and business performance are all on the line?
That's right. Don't think, know. Now, we monitor different types of furnaces in different applications, from small batch furnaces to large annealing and galvanizing lines. And CMA is easily retrofittable on both open fire and radiant tube furnaces. And the dashboards clearly present fire rates and air fuel ratios in real time. And yet there's so much more power in the data available through CMA.
Right. So today we're going to break down how monitoring allows you to diagnose other potential furnace or operational problems, such as clogged combustion air filters, radiant tube cracks, bad regulators, and more.
So here we're looking at data from an open fire batch furnace dashboard, and we focused in on a specific date range where you can see air pressure to the 4 burners. And starting around May 26th, you can see a gradual decline in air pressure to the burners. Now, this is an indication of air filter clogging. When the system detected that steady decline of pressure, we were able to alert the customer to get this clogged filter cleaned, returning the furnace back to full power. Now, had there not been monitoring on this furnace, the filter would have continued to clog, the furnace would have become further and further underpowered, running rich, causing more soot and carbon and emissions.
Seeing this and correcting it quickly helped this customer avoid potential quality issues and unplanned downtime. Now let's take a look at a radiant tube example. So those customers who run radiant tube furnaces with a controlled atmosphere understand the impact that a cracked radiant tube can have on furnace performance.
Yes, having oxygen inside the furnace is going to significantly affect the surface quality of the product. So knowing when a tube is cracked is critically important. And usually, tube cracks will require shutting down the furnace, obtaining a confined space permit, sending someone from your team inside the furnace to actually manually inspect the radiant tubes.
Right, and with CMA, the process is very simple. So first you shut the gas off to all of the burners in the zone, filling the tubes with combustion air. And then you shut off the combustion air. And if the tube is cracked, atmosphere from inside the furnace will leak into the tube and drop the oxygen levels in the tube. So if it is not cracked, the oxygen readings in the tube will remain at 20%. And as you can see in this graph, 2 of the tubes were clearly cracked as they dropped to 3% and 10% O2. The tube that dropped slightly just had some carbon deposits in that tube that were combusting, which slightly can drop the oxygen levels. The customer cleaned that tube out, tuned it, and performed the crack check again to determine that there were no cracks.
So checking the entire 5-zone furnace took less than an hour to complete. With the CMA system, tube crack checks can be performed in just minutes per zone without shutting the furnace down. As you can see from the example, within 5 minutes, we were able to see which tubes in the zone are cracked by observing the oxygen percentage in each tube of the zone. And being able to quickly check for cracked tubes without shutting the furnace down allows CMA customers to virtually eliminate quality issues due to cracked tubes.
Another great example of the power of the data is shown here, where we're monitoring combustion air pressure at the zone header of a really large austenitizing furnace in the steel industry. So setting the motorized control valve properly is critical to achieving efficient furnace performance. And what can be seen in the data is a valve whose cam is set incorrectly.
Yeah, this cat ear shape is a simple indicator of an MCV problem.
When the controller asks for high fire, the cam rotates to the max position. And typically the cam would be set just before max output. But in this case, it was set past max output. So as it opens, it peaks at max and then drops down and remains steady until the controller calls for low fire. So when it calls for low fire, that cam reverses past max again and then closes the valve completely. Without CMA on the furnace, this problem would be very difficult to detect.
Right, and here you can see what the properly set MCV response should look like. The controller is asking for high fire, and you can see the valve is delivering it. Now, if this problem was not addressed, the furnace would have continued to operate at less than maximum output, and the operator would have been unaware until there was a quality or line speed issue. Okay, so we saw a bad MCV setup. Now let's take a look at a bad ratio regulator. So this data is showing excess oxygen at the burner level of a small zinc melting furnace. In the bottom left of the excess oxygen panel, you can see that excess oxygen in burners 1 through 7 is around 2.8 to 3.2%. Now this indicates that it's a very well-tuned system that's operating at high fire.
And when that controller calls for low fire, you can see all of the burners react except for burner number 5. So burner 5 stays at 2.8% O2 when all of the other burners jump to about 10% O2. This indicates that the regulator on this burner is not functioning properly. And again, without this data delivered from CMA, the operators would never see this problem, and this tube would likely burn out way before the others in the zone.
Now, the CMA system is capable of monitoring much more than combustion at the burner level. And this is actually data taken from our own operations at PS Energy, where the CMA system is monitoring temperature through various cycles. It's monitoring power input. It's monitoring vacuum and pressure, and actually even door position, all of which are critical to the quality of our products. Additionally, we're able to see the total number of cycles in any given period of time as well.
And having the CMA system in our process gives us peace of mind. Not only do we know that our furnaces are operating optimally, but we're certain that the product going out the door meets our high quality standards. So let's take a look at another example of how the data is used to troubleshoot. But in this case, the data was all positive, taking combustion off the table as the root cause of the problem.
Yeah, and that's equally powerful data. Knowing that combustion is running well gives you a firm foundation from which to make decisions and troubleshoot. Now, this CMA customer with the normalizing furnaces in the steel industry called our team concerned because the controller said that they were not making temperature in zone 1.
We knew that their daily report, which is shown here, showed all burners in the zone were within optimal range, meaning that the furnace was tuned well. So we pulled up their dashboard to review with them in real time and found that combustion, like I said, was running really well in that zone. We were confident that combustion was not the problem. So with that data, we quickly moved to the thermocouple and asked them to check it. And sure enough, the thermocouple was damaged and they replaced it within minutes and solved the problem. But without that data showing that combustion was not the problem, they would have chased this undertemping issue for some time. So let's wrap this up by highlighting the key points from our series so far.
Right. If you're in metals or heat treating, furnace performance is business performance.
Combustion is simply chemistry, so there's only one right way to run it.
And don't think, know. And knowing is easy with CMA.
CMA delivers more than air-fuel ratios, and it gives insights which allow your team to run your operations much more efficiently.
And lastly, PS Energy is your trusted combustion partner. As always, if you have any questions, feel free to comment or reach out to us directly.
Yeah, and thank you for taking the time to join us today. Make sure to give us a call when you're ready to join the growing list of metal processors implementing this technology across the country.